For those of you following along with this enterprise infrastructure build, I said it was going to be a budget environment. And as such, what I want to do is I want to ask you a question. What would you say if I told you that for an additional $200 today, you could build a complete and functional software-defined access environment for the use in your enterprise infrastructure studies? Well, I was amazed, and I've been able to make it work. And more to the point, I'm going to show you exactly how. For those that don't believe me, this is our lab. As you can see, there's not a lot to it. Right now, I have the one server that I'm using, my R630, that I'm using for my ICE engine. I'm using it to operate my gateway router, which is a CSR. I'm using it to run my identity services engine. And everything that we've done in the lab thus far has been done on this specific environment. Now, as a direct result of that, that brings into everybody's mind a bunch of questions. First and foremost is going to be, well, Terry, if I've only got one switch and I'm using, as you can see, a 3650, a $200-ish at the time of the making of this video on eBay switch that's going to allow me to be able to create an edge in my environment, but it won't do anything else. So what am I going to use for my border and my control plane node? Well, we're going to use a CSR 1000V running in that R630 server. Now, as a direct result of that, that means that I need to talk about the resources that I want to be using in the implementation of this lab. Now, what I'm going to do is I'm going to go to my vSphere environment, and what I want to do is I'm going to take a look at that server. The server that you just saw in that picture is 10.1.0.117 in my lab. Again, remember, it's an R630 server, and it's running an E5-2689V4 CPU. In fact, it's running 2 of these Xeon CPUs, and that's giving me a total of 80 CPUs. Of those 80 CPUs, I am throwing 62 of them at my mini DNAC. Let's take a look at that. If I go to my summary, we can see here that I'm using 62 of my overall CPU space. This server cost me about $2,900. It has 6 terabytes of solid-state storage. It has 512 gigs of RAM and the 2 CPUs that I just described. You may be able to find one cheaper. I actually have about 4 or 5 of these that I'm using in my lab environment to support my students. But this isn't about students. This is about building a cheap, affordable, let me rephrase that, an affordable home lab, and to be able to get the most out of our spend. Now, what I'm going to walk through is not going to be identical to what you're going to see in the lab exam. Bear in mind that a 9300 Catalyst switch is a switch. It's layer 3 capable, but it's still a switch. A CSR is a router, so they are fundamentally different. But it's still going to give me the ability to be able to create a fabric and interconnect that fabric to my SD-WAN infrastructure that I'm going to be using for transit with regard to being able to do proof of concepts and labs that are going to help us prepare for the exam. So when I look at what I've got going on here, what I've done is I've created a CSR 1000V, and that CSR 1000V is going to be my border node. This device is also going to be connected to a physical 3650, and if I take a look at my secure CRT session, all I'm doing is I'm using that blue rollover cable that you see right here is connected to the back of my server and is connected to the console port of my Catalyst switch. And as a direct result of that, I can access it from a console perspective. Now, what I have done is I've installed some baseline running configuration on both of these resources. We can see that in the 3650, which is going to be my BR1 Edge-1 device, I have this config, and it's the bare minimum configuration to get things operational. Please note that I am running OSPF in my underlay that I'm going to be using to demonstrate that this is going to be possible. And we also see that my CSR 1000V is going to also be connected to the same network environment as my identity services engine and as my DNAC. So as a direct result of this, it's going to be important to understand that I'm forming a peering relationship between this CSR and this edge device through the utilization of the network of 10.11.12.0/24, where 11 is on the CSR and 12 is going to be on the 3650. Now, as a direct result of this, I've pasted this configuration into these devices already. So what I want to do is I want to do some baseline verification. So I'm going to log in using the credentials for the lab, which is going to be cisco, and I'm going to do a ping. Now, when I ping 100.64.0.201, that's the ID of my ICE engine, we can see that I can reach it. And if I implement a trace route to that same address of 100.64.0.201, and I'm going to say numeric because I don't want to do DNS resolution, we can see that it's traveling up to the CSR, and ultimately from the CSR, it is going to be delivered to the DNAC and to the ICE engine. In this case, I'm testing the ICE engine, but we can see that my data is indeed moving through my network here. So let me go ahead and stop this. And like I said, I can ping 100.64.0.201. And I can ping 101. Remember, that's the IP address of my DNAC. So let's see if that's working. And what we're going to find here is that it is not working. Now, the reason it's not working has nothing to do with anything other than a mistake that I made in my environment because I've been building this ad hoc. Now, the problem is that if I take a look at the Identity Services Engine, we have a gateway of last resort that's sending traffic back to the router that is servicing as our exit, our egress off of network segment 100.64.0.0/24. Now, the problem is that for this edge device to be able to reach out and communicate to the Identity Services Engine, the Identity Service Engine does not know how to get traffic back to this device. And that traffic is being sourced from 10.11.12.0/24 as a network. So if I were to access the DNA center, let's get into the mini DNAC. And what I'm going to do from here is I'm going to say, can I ping 100.64.0.11? That's going to be the device that is my CSR 1000V, which is going to be my CP border node. But again, I cannot ping 10.11.12, let's go ahead and say .11, which is on that same device, that same CSR. And again, this should come as no surprise. This is just straightforward routing. There's nothing special here. So what we've got to do is we need to modify the routing table on our DNA center. And we'll have to do that from a Linux perspective. And to fire that off, we're going to need to get into the configuration utility that we used to build the DNAC in the first place. So let's go ahead and stop this ping. And what I'm going to do is I am going to type route-in pipe more, and we're going to look at this routing table. Now, we see that we have a routing table that is going to be the gateway of last resort is going out of 10.1.0.1. We see that we have 10.1.0.0, which is my internal network, and we also have 100.64.0.0, which is the network that we built that's going to be part of our enterprise infrastructure. But the problem is that the system doesn't know anything about 10.11.12, nor does it know about the loopback interfaces that I also want to use in my lab. So we need to modify that. So what I'm going to do is I'm going to do sudo su so that I can access elevated privileges. I'm going to log in using the ICE's cool password that we opted to use. And I'm going to type maglev-config space update. And that's going to fire off that installation wizard that we utilized earlier. And what we're going to see here is that on the network adapter that is going to be facing the enterprise, adapter 1, this is, remember, our enterprise network interface, I need to provide some additional information because I don't want to have two gateways of last resort on this server. I still want to keep the 10.1.0.1, which is the gateway out to the internet, so I can get updates, I can communicate to Cisco, and I can do everything that I need to do. But I also want to make certain that I am going to send data to the proper resources inside of my lab environment. Now, as a result of that, I need to enter some static routes in order to be able to make this possible. This is optional. You don't have to do this. You could have built your lab differently. But again, I've been expanding my lab as I am going, and I'm kind of creating this on the fly. So what I want to do is I'm going to tell the system to get to the network of 10.11.12.0 with the network mask of 255.255.255.0, send that traffic to 100.64.0.11. That's the IP address of that CP border node, which I know is reachable because that IP address is on that VLAN 64 segment. Then I'm going to enter space. Now, the next thing I'm also going to want to do is every one of my devices will have a loopback address that I'm going to use later on for the purposes of VXLAN formation. That is going to be my VTEP. And that is going to be in the 100.124.0.0. And I am going to use the slash, and I'm going to put in 255.255.255.0, and I'm also going to send that to 100.64.0.11. Now, be sure that you have a space between these routes when or if you ever use this approach to be able to resolve reachability in your lab. Now, what I'm going to do is I'm going to go down to Done because I'm not going to enable that cluster link. We're going to go to Proceed. And let's see what the system does. We'll answer any questions that it puts in front of us, but it should validate the host configuration, the IP addressing, and everything, and apply my fix, my patch. Now, obviously, this is going to take a little while. We'll wait on it. I'll accelerate it in post. We can see now that it's asking me to provide those cluster virtual IPs. Remember, we opted not to use those, so I'm just going to go ahead and say next. Now it's going to ask me to reapply the password for Maglev, which again was ice is cool. I'll repeat that. Ice is cool. We're not going to do any of the password generation or the auto generation. I'm going to go ahead and hit next. Confirm that we're still using time.google.com for my NTP. The system will validate NTP. We'll go ahead and proceed. It's going to configure NTP. And we can see that it has made the corrections. Now that we've completed the static routes on the DNAC, what I want to do is I'm going to repeat my ping test. I'm going to ping 100.64.0.101, and I'm going to source it from my loopback 0 interface on Edge 1, and let's see if we have reachability, which we do. I'm going to go ahead and repeat the exact same test going towards the ICE engine. Now what we see is we have all of the reachability that we need to allow the DNA center to communicate to these devices and to allow these devices to communicate to the Identity Services Engine. This is extremely important because unless the DNA center can connect and log into these devices, the DNAC cannot manage these devices. So the next part of this is going to end up being moving toward the idea of implementing changes in the DNA center. The next step is going to be to access the DNA center. And from the DNA center, we need to put in the necessary configuration to allow us to be able to discover devices. Now, what I'm going to do is I'm going to create a hierarchy. I'm going to create servers. I'm going to apply credentials, and we're going to do a discovery, and we're going to get these resources such that they're going to appear in our DNA center so that we can create an SDA fabric. To do that, we're going to have to go through the design phase of our implementation, whereby I am going to create a site, and that site is going to be an area, and I'm going to call that site Super University. Once I created Super University, what I'm going to do is I'm going to add a building number 1, and I'm just going to click a location over here, and we are going to apply this config. So for my address, what I'm going to do is I'm going to say, we'll pick a RTP. We'll say Kitts Creek, Morrisville, North Carolina, and we'll just put a little marker on the screen here. I'm going to go ahead and say add, and that should create my first building. We'll go ahead and create a second building. So we'll say add another building. This is going to be building 2, number 2, and we'll just put it like right here. So in fact, let's move it over here. And again, we will specify Morris. So Kitts Creek, Morrisville, North Carolina. And we'll say add. So I've got 2 little placeholders here for buildings. And all I'm going to want to do at this particular juncture is move on to the next phase. We have a hierarchy. I'm going to go back up to global. I'm going to go to my network settings, and we're going to define network resources. I'm going to need to use that Radius server and the TACAX server that's going to be running inside of my ICE engine, and I'm going to go ahead and specify an NTP server. So what I'm going to do is I'm going to say we're going to enable AAA for network and for clients and endpoints. We're going to use ICE for both. I'm going to go ahead and select the ICE engine out of my drop-down menus. And again, this is not meant to show you guys how to do this. It's meant to get enough configurational settings inside of the DNA Center to allow us to be able to implement a discovery so I can show you guys how we would quote-unquote build a fabric. So for networking, I'm going to employ TACAX. And I'm going to use the policy service node located on my ICE engine. And for my client endpoint configuration, I'm going to continue to use Radius. And again, I'll select that policy service node. My DHCP server in my lab is going to be located at 99.99.99. That'll be in the headquarters office that is going to be connected via the SD-WAN environment. The DNS server is also going to be in the same spot, micronixlab.com. And located at 99.99.99.99. Syslog server will be my DNAC. SNMP server will be my DNAC. My time server is going to also be located at 99.99.99.99. And I'm going to go ahead and specify a time zone of EDT, and I'm going to hit save. Now, what we've just done is created the hierarchical constructs that we're going to be using, servers that are going to be utilized by resources in different areas and regions. We've also created the network hierarchy, which is going to be the buildings and the sites that we're actually going to be using DNA Center to manage. So what we want to do next is we want to make certain that these resources are indeed going to be available in each of these levels. So what I typically do, and this is just me, I will go ahead and I will save these settings on each of the individual logical constructs that I've set up. Now, the system is going to tell me that they're going to be inherited, but again, in these older versions of DNA Center, I have a tendency not to trust that inheritance. So again, just belts and suspenders here. I'm going to go ahead and apply these to each of the respective areas. Next thing that I'm going to need to do is I'm going to create device credentials. I'm going to navigate back to global, and I'm going to create the credentials that the DNA Center is going to need in order to be able to log into these devices. The first one is going to be the credentials to access my IOSXE devices. And we are going to use the username of netadmin. Remember, that is going to be the user that is on my devices and configured in my identity services engine. I'm going to use ICE is cool for the password, and also I'm going to use ICE is cool for the enable password. Let me go ahead and hit the eyeballs here and make sure that I didn't mistype, which I have such a bad habit of doing. Thank God for that option. I'm going to go ahead and hit save. Next, what I'm going to do is I'm going to create my read credentials for SNMP, Simple Network Management Protocol. And this is going to be RO, RO, read only, read only. I'm going to go ahead and create my write credentials. I'm just doing SNMP v2c because it's the easiest. And this is going to be read write and read write. And again, this needs to be configured in such a way that it's going to be on and running on my devices. Now, what I'm going to do here is I want to make certain that these features, these credentials are selected. So I'm going to hit the little dot next to iOS XC devices. Under the read, I'm going to select the read only, and under the write, I'm going to select the read write, and then what I'm going to do is I'm going to save. Also, as a direct result of being paranoid of these older versions of the DNA Center, I am again going to repeat this process on each of the hierarchical levels that I created. Again, this is just my version of belt and suspenders. We want to make certain that these are still blue on each of these levels. Blue. And lastly, building 2 will also be blue. Now, we're not done. We need some IP address pools that we're going to create. Now, the first one is going to be created at the global level. I'm going to add it, and I'm going to call it my global IP pool. And it is going to be 100.0.0.0/8. And I'm going to go ahead and specify gateway of last resort. I don't need one. I'm not going to do DNS or DHCP because what we're going to do is we're going to carve chunks of this address out, range out, and we're going to use them in our respective buildings. So what I'm going to do now is, now that I've created this pool, I'm going to go down to building 1. And from the perspective of building 1, I'm going to start reserving blocks of addresses out of that range. I'm going to create 4 blocks. My first block, actually, we'll create 4 blocks. We'll do campus, we'll do guest, we'll do layer 3 handoff, and then what we'll do is we'll actually do an IoT. So my first IP pool is going to be campus, and I'm going to pull those addresses out of that greater range. I'm going to make them /24. And it is going to be 100.1.101.0 with a gateway of last resort of 100.1.101.1. And I'm going to go ahead and select my DHCP and DNS servers out of the drop-down menu. Remember, these are the servers that we created when we built our network settings under services, under the network tab. Now you see here I have a range of addresses that I'm reserving for campus. Let's go ahead and make the others. I'm going to reserve a block of addresses for all of my guest networks. Again, I'm going to pull it out of the global pool. It is going to be a /24. And what I'm going to do is I'm going to use 100.1.102.0 with a gateway of last resort of 100.1.102.1. And again, I'll pull the DHCP servers and the DNS servers out of my range. Next one is going to end up being my my layer 3 handoff. And that is again going to come out of this range here. It is going to be a /24. And I'm going to use the network of 100.1.103.0 with a gateway of last resort of 100.1.103.1. I'm not going to worry about DHCP servers or DNS servers. The next thing I'm going to do is I'm going to reserve a block of addresses for IoT, the Internet of Things in my environment. Again, I'm going to pull it out of the IP pool. I'm going to do /24. And what we're going to do is we're going to specify this as 100.1.104.0 with a gateway of last resort of .1. And I will go ahead and pull my DHCP and DNS servers out of my list. So right now I've got a block of addresses that I'm going to use when the time comes to implement virtual networks. Now, what I want to do at this particular instance is I need to get devices into the DNA Center in order for me to be able to configure them. think of the DNA center as a minion. We are going to provide the DNA center instructions based on how we're going to notify it of our intent with regard to the configurations that is going to be applied to devices. But before we can do that, those devices have to exist. They have to be in our inventory. So if I were to go to provision and take a look at the inventory subsection and go all the way up to the global config, you're going to see that we have no devices to manage. We need to add those devices, and we're going to add our virtual CSR 1000V, and we're going to add our physical 3650. Let's go ahead and make that happen. To do that, I'm going to go to the tools icon. I'm going to select it, and I'm going to say I want to implement a discovery operation. I need to find those devices that we implemented. So I'm going to add a discovery process, and what I'm going to do is I'm going to call this IOSXE discovery. And I'm going to tell it I want to use a range of IP addresses to implement this discovery. The range of addresses that I'm going to use is going to be 100.124.011 to 100.124.012, and I am opting to use the loopback interfaces. That's my choice. I don't have to. I could just use the physical addresses, but right now I'm going to opt to use the loopback addresses because it's my preferred method. By default, we can see that we're using a CLI credentials that we configured. That's going to be netadmin and ISIS cool, and we're going to have the read-only of RO and the write of read-only of RO and the write of RW for the SNMP configs. And what I'm going to do is I'm going to tell it that I want it to start the discovery and I want it to do it now. Now, what I'm going to do is I'm going to wait a little bit, and I'm going to hit this little X here because this is covering up the status of what's going on in my DNAC. We want to go out and see if the DNAC can access these devices and add them to our inventory. So the hope here is that the DNAC is going to SSH to these devices. It's going to leverage the credentials that we provided. It's going to do everything that we set up, and ultimately it should be able to find these two resources, meaning the CSR and the 3650 that we implemented in our design. And we can see here on the screen that it has actually done that. Notice it's found these devices. Now, before I proceed, what I want to do is I want to make certain of one thing. I'm going to open up my session to my device, which is my physical 3650. I'm going to log into it. ICE is cool. And I am going to do config T, and I want to make certain that my licensing is correct. Now, first I can say show license usage, and what we're going to find here is I am actually using the IP services license, and I am running the DNA Advantage license. This is extremely important because without these licenses, I cannot make this device part of an SDA Fabric. But don't panic. This is right to use. So if you do not currently have the correct licensing, we can fix that. However, it is going to be important that we understand that we need/want to also make certain that we're running a version of the Catalyst operating system that's going to support this feature. So on my specific device, if I say show version, I think that I am 16.12.07 Gibraltar. Now, if you do not have or you do not see under show license usage, the IP services license and the DNA Advantage license, don't panic. Simply type config T, and we're going to say license boot level. And what we're going to do is we're going to select the IP services, 9K, and what we are going to do is we are going to add on, and the service that we're going to add on is going to be DNA Advantage. That's going to give us all of the capabilities. So it'll be DNA Advantage. which is going to give us all of the functionality. And then the system is actually going to say that we need to write this, and that license will take effect on the next reboot. Now, I don't have to reload. I just wanted you guys to see exactly what's involved with this. A lot of people on eBay are trying to sell switches, 9300s, 3850s, 3650s, and they're touting that they are licensed for DNA Advantage. And they're tacking on an additional, 200, 300, sometimes even more to the price of the device. You do not have to worry about it. I bought this guy for, I bought this one for $134 on eBay about a month ago. Prices are gradually going up because people are learning about what I'm teaching in classes and showing how to build home labs. And now I'm doing it on YouTube. So, expect those prices to continue to go up because, at one point, like 2 years ago, you could buy these things for like $80. But now they're getting closer up to like the $200 and sometimes higher price range. But don't get swindled. Right now, we can leverage this for the purposes of a right-to-use license. Even when it expires, it's still going to work. It's just going to throttle throughput. There's going to be detractors for trying to use this in a production environment. But what I want everybody to understand is that it's not necessary for a lab. But it must be configured and running those two licensed states, IP services to be able to run the routing protocols, and DNA Advantage in order to be able to support everything that we need to have supported in our lab. The good news is you don't have to worry about the CSR 1000V. But let's take a look at it while I am here. So what I'm going to do is I'm going to take a look at my CSR 1000V because, once again, it might be significant because not all CSRs are created equal. So what I'm going to do is I'm going to log into this guy. ICE is cool. And what I'm going to do is I'm going to say show version here. Now, I'm going to be running Amsterdam, if I remember correctly. So, yes, I am. So, I can't highlight, unfortunately. But we can see right here, I'm running version 17.3.2. I recommend this or higher to accomplish what I am trying to accomplish with regard to building out a functional environment so that we can have an operational lab. So, with this done, what I'm going to do is I'm going to go back to my DNA center. We see that we have these devices. What I'm going to do next is I'm going to provision these. So what I'm going to do is I am going to go to the DNA Center tab. I'm going to go to Provision, and under Inventory and Unassigned Devices, I've talked long enough now to where we should see that we have a BR Edge 1 and a CP Border Dash 1. Those are the two devices. My virtual CSR 1000V and my physical 3650. Now, what I'm going to do is I'm going to highlight these. Now, these are two separate devices. So what I'm going to do is I'm going to take the CSR first. I'm going to select it. And what I'm going to do is I'm going to say that I want to provision this device. I'm going to provision this device in Super University at Building 1. Building 1 will be branch 1 in our environment. Building 2 will be branch 2. And the two branches will be connected using SD-WAN. I'm going to go ahead and say select next. I do want to call out that if you have trouble selecting next or any of these options, move your mouse around until the icon turns dark and then it will take the command. I'm going to go ahead and say next. I'm not going to be running any templates, so I'm going to say next pass advanced config. And then ultimately what I'm going to do is I'm going to say let's go ahead and provision that device. Now, since this is a router, I have to provision routers in groups, and I have to provision switches in separate groups. So I can't provision them both at the same time, which is why I'm selecting this process. Next, I'm going to do the edge. So we'll again select provision. I will go down to provision device, and I'm going to put it in Super University Building 1. And deploy. Do it now. These resources should ultimately transition. Notice nothing is showing up inside of unassigned devices, and if I navigate down towards Building 1, I should see those resources in Building 1, and if I navigate to Building 2, you'll note that there are no devices provisioned here. If I look at it one step higher for Super University, what we're going to see here is these resources are going to show up because I can see everything indented under the hierarchical construct that is going to be my site or my area or whatever we're calling it, super university at this point. Now, the overall exercise of this was to demonstrate that for $200, you can build an SDA Fabric. However, we haven't built a fabric yet. So let's go ahead and make a fabric and see if we can't get that deployed. I'm going to go to the Fabric tab under Provision, and I'm going to say I want to add a fabric. The fabric that I'm going to add is going to be anchored on Building 1, and we're going to call this fabric, actually, you know what? I'm going to call this fabric Super U. And let's go ahead and say next. Now, I'm going to pick the networks that I want to include in my fabric. These are the only ones we have. And again, this is not a class on how to use the DNA Center. This is a class on how to build a lab. I'm just demonstrating the functionality, and I'm demonstrating the fact that everything that we've got in our inventory at this time is sufficient to the task of creating a functional software-defined access environment. So what we're going to do next is I'm going to go ahead and just add these, and it should create that fabric for me. I'm going to select that fabric. I'm going to take a look at Building 1, and I should see 3 little icons in Building 1. I should see a cloud, I should see a router, and I will see a switch. Well, at this particular juncture, that's all I have. Now, ultimately, this is going to be Gigabit Ethernet 1 going out to the internet. That's what I'm using for the management. This is going to be Gigabit Ethernet 2 that is going down towards my Bridge 1 edge router. And I enabled CDP inside of my ESXi switch inside of my VMware config so that I can see this link. If you don't see this physical link, that's because you are not using CDP in anything other than listen mode. My recommendation would be to change it to both. I showed students how to do that in class. But ultimately, what I really want to do at this particular juncture is recognize that Gigabit 3 will ultimately be going up to my vEdge, but we're not there yet. What we want to do now is we want to demonstrate that this is going to work. In order to make this work, I am going to just do the basics. I'm going to go into the CSR1000V. I'm going to make it a control plane node. In other words, it's going to install Lisp. I'm going to make it a border node. That means basically at the end of the day, it's going to run BGP. Right now, none of those configurations are installed. Before I implement it, I will show you. Second, I'm going to go ahead and make the 3650 an edge device. And that means it's going to ultimately end up having the ability to have devices connected to it. And it's also going to be a Lisp client. Let's go ahead and see if we can't get that implementation in place. To do that, I'm going to click on the border router, which in this case is an actual router, and I'm going to say make it a control plane node, and I'm going to say make it a border node. Now, to do this, like I said, I need to have some fundamental stuff. So I'm just going to say use an autonomous system number of 65001. We're not going to worry about building a transit network yet. Again, I'm just demonstrating the fact that we can build a fabric, the bare minimum, taking the path of least resistance. In class, we talk about how to build transit peer networks, and it's not hard, but at this particular juncture, I'm not adding it to the mix. So what I'm going to do is I'm going to go ahead and say add. Now I'm going to go ahead and click Add down here as my Add button. But before I do anything, let's go ahead and take a look at the running configuration on that device. So what I'm going to do is I'm going to SSH over to my CSR. So let's go ahead and say this will be netadmin. And I'm going to go ahead and connect to 11. Let's see if this works. ICE is cool. And you can see I'm on the border node. And if I say show, run, pipe, include Lisp, I have nothing in there. If I say show, run, include router BGP, I have nothing. It's also important to note that I do have show, run, pipe, include AAA. I should have all kinds of AAA configuration that was applied by the DNAC when I added this device to my fabric, when I went ahead and provisioned it, I guess is a better way to say that. This has nothing to do with fabric. This is a result of the provisioning process. So as a direct result of what's going on now, this device is now ready to assume whatever role I assign it inside of the DNA center. The next thing that I'm going to do is I'm going to go ahead and click on my edge device, and I'm going to make it an edge node. I'm going to go ahead and hit add. Now, at this particular juncture, I need to tell the DNA center to deploy my intent, and I do that by selecting Save and Apply. And the system should go out and apply the appropriate configuration to meet the criteria of my intent. We'll wait and we'll watch. When the devices turn solid blue and they remain solid blue, we're done. So as an example, my validation for this is to click off and click back, or you can click on the device itself, go to the Details tab, scroll down, and you want to see the words success. You don't want to see the configuring. So we're still in the process of getting this to do its thing. Notice now it says success. Now that 3650, it's old as dirt, so it's going to take it a little bit longer for it to go through all of its paces, but at the end of the day, it's a guarantee that it's going to work provided you set up the licenses and you follow the instructions that I provided. And again, it's just a $200 switch. We can't expect too much from it. And it is still going to give us the ability to be able to implement our lab so that we can play with all of the features and capabilities, to include SDWAN as transit. However, again, like I said, there are some things that we can't do. This isn't a perfect scenario. We cannot do LAN automation using this CSR 1000V as our seed device because it doesn't support layer 2 interfaces. The other thing that is also going to be important to note is that it will work as a border node, and it will connect to a vEdge using SD-WAN as transit, but it will do it differently. We will need sub-interfaces running .1Q encapsulation on those sub-interfaces on this CSR 1000V. Don't panic. The DNAT can take care of that for us. However, that is fundamentally different than what would happen in, say, a 9300 or a 3850 that's acting as a border control plane node in this specific instance. That is going to configure a .1Q trunk, and it's going to use SVI interfaces on that switch in order to be able to form those adjacencies with that vEdge that we're going to be using as transit. The other thing that it will not do is it will not support the concept of fabric in a box. However, creating a fabric in a box is no different than just making it a border node, making it a control plane node, making it an edge node. If a switch is all three of those things at one time, it is fundamentally a single unit fabric that they call a fabric in a box. It's not worth $3,000 to $4,000 in my personal opinion to buy a 9300 in order to be able to just do that one thing. So save your money. If you want to be more specific, if you want to be closer to the mark with regard to the behaviors, go ahead and buy yourself a 3850. 3850s are anywhere between $500 and $650, and they can be borders, they can be control planes, they can be edges. They just can't be all three at one time. So in other words, a 3850 will not support a fabric in the box architecture. The only device that you're going to be able to use for an FIAB is going to end up being a 9300 or higher. So again, I've built an environment that's fully functional. Let's check that out. So right now, this guy, if I hit refresh, it should come up and say he's succeeded. So we have a success. We have built our infrastructure, and we have an SDA Fabric that we can now manipulate and take on into our next steps. And to validate what I'm describing, let's go ahead and take a look at what's going on this device. If I say show run pipe section router Lisp, we should have Lisp configuration now. It is now a Lisp server. Let's type show run pipe section BGP. It'll barely be there, but it will be there. I have that autonomous system that I created. So what we've illustrated here, beyond a shadow of a doubt, is that I have all of the functionality that I need in order to be able to continue to lab. Not being able to buy a 9300, not being able to go out and buy a 3850 is not an impediment to study. In fact, you could do this exact same scenario in branch 2, create a CSR 1000V, acquire a 3650, attach it to that CSR 1000V, and do the exact same thing in branch 2. Connect your hosts to your 3650s, which we'll cover in a later video, and all of a sudden, you're off to the races. You can send traffic back and forth between the branches, transiting the vManage, which we have yet to build in this environment, but it's going to be a very simple process to set it up, to validate it, and to make certain that everything is working. So I hope that this has been helpful, and I hope that this is demonstrating the fact that the bulk of our expense, meaning the server, that we are going to be using to run our Identity Services Engine, our DNAC, our CSRs, our jump box in my instance, or 1 or 2 servers that you acquire that don't necessarily cost as much together as one of these larger servers that you can distribute things across. Just bear in mind that you need a minimum of 62 CPUs to make certain that your DNAC is going to be stable. So I'm hoping that this was helpful. I'm hoping you guys are still able to track with me. And then ultimately, what we're going to do is we're going to build the next part of this, which is going to be the VMware environment. And I'm going to use a combination of 2 options. I personally like to implement Eve as my solution. I have all of the UNL information, all of the configuration, how to set up that environment without having to go through the certification process that I'm going to share in a subsequent video. Once that's up and operational, we're off to the races. We're actually able to lab. So I'll see you guys in that next video. Until then, keep labbing, keep studying, and I hope to see you soon.